So I'm only allowed to record 5 minutes, so that one cut me off. But here's where I was going with that. Near -3 from the right, something close to -3 but a little less negative, plus 3 gives us a positive number. Negative divided by positive is negative. Since the left limit and the right limit are different, the limit as x goes to -3 does not exist. The limit as x goes to 0 on g of x, well, let's see. There's nothing in here that would make the function undefined, so I just plug in 0 for x, so 0 plus 5 is 5, 0 plus 1 is 1, I get 5 over 15. This is going to be 1/3. The limit as x goes to 3, so 3 is a problem in the original function of g, but it's not a problem in this version. Remember we had to eliminate it, so that means there's a hole at x equals 3. But in this version, it's continuous, so I just need to plug in the 3. 3 plus 5 is 8. 3 plus 1 is 4, so that's going to be, let's see, that's going to be 8 times 4 divided by 5 times 3 plus 3 is 6. So that's going to be 32 divided by 30, so 16/15. And the limit as x goes to infinity, again, we're looking at the opposite of x cubed. I'm sorry, just x cubed. That was from before. X cubed divided by a 5x squared. As x gets really big but positive, those are both positive. This is going off toward infinity. Problem number 3, I'm going to get a little bit more room on this one. Problem number 3, remember when there's a radical involved, it is often helpful to multiply the numerator and denominator by the conjugate of the thing you're trying to get rid of. Well, let's check it out first. Is 0 a problem? If we plug in 0 for x, I'm going to get root 7 minus root 7. So the numerator is going to be 0 and the denominator is going to be 0. That's the problem we have to run into, we have to avoid. So sometimes you can avoid that by multiplying top and bottom by the conjugate of the numerator. I'm not going to worry about the 2 right now. I'm just going to deal with the radicals. So I'm going to get the limit as x goes to 0 on 2. When I multiply these two guys together, root 7 minus x times root 7 minus x is just 7 minus x. I'm going to get plus root 7 times root 7 minus x minus root 7 times root 7 minus x, so I don't worry about that one. And there's going to be minus root 7 times root 7 is 7. My denominator is going to be x times root 7 minus x plus square root 7. So let's see, that's going to be the limit as x goes to 0 on, oh, that's nice, that's just 2x in the numerator, x times root 7 minus x plus square root 7. And look at that, the x's divide out to 1, and I get the limit as x goes to 0 of 2 over root 7 minus x plus root 7. And now as we go to 0, that goes to 0. So the whole thing gets closer and closer to 2 over root 7 plus root 7, which is 2 divided by 2 root 7, which is 1 over square root 7. So multiplying by the conjugate of that radical expression did help a lot. And then finally, we've got this problem. The limit as h goes to 0 of f(x) plus h minus f of x divided by h. Regardless of what f of x is, if h is 0, I'm going to get f of x minus f of x, which is 0, divided by 0. So I've got to do something about this. So let's insert 5x minus x squared for that and go from there. So I've got the limit as h goes to 0 on 5 times x plus h minus x plus h squared, and that's all from this guy. The input times 5 minus the input squared. And then I've still got to do minus f of x, 5x minus x squared, all over h. So I've got the limit as h goes to 0 on 5x plus 5h minus x squared minus 2xh minus h squared minus 5x plus x squared, if I simplify all that out, divided by h. You notice a whole bunch of things drop out here. I've got the limit as h goes to 0 on all of that. That goes away, that goes away, that goes away, that goes away. And that's it. So I'm going to end up with, something else happened here. I'm going to have to go back and fix this one, I'm afraid. Take a look at it on the notes page. Thanks.